So I am recording. Feel free to stop me. It's all good. I could always pause and continue recording later. This is actually my second video for reviewing for the midterm. Why does it say spring midterm review spring? What the heck? Okay, so let's just say midterm review spring 2024. And like I said, this is the second video on this is on exponent rules and also growth and decay functions. The first video was on solving systems of equations. And this is the second one that we're making on exponent rules and exponential growth and decay functions. So let's start by jotting down the title in your notebooks, Unit 7, Exponent Rules and Exponential Functions. So if you go back to Google Classroom and you scroll down to section 7.2, you're going to find this PDF right here of notes. And this has every single rule of exponents, right? So we need to know rule 1, that if you are multiplying two terms with the same base, what do? Add the exponents. That's how you get x to the 5th. If you have a power to a power, what do? Multiply them. That's how you get 6 right there. If you have a monomial on the inside, what do I mean by monomial? It's just one term, 2x squared y is e to the 5th. It doesn't say 2x squared minus y is e to the 5th or 2x squared plus y is e to the 5th. It's just a monomial to the third power. So when you have a monomial to a certain power, you could distribute the outside exponent to each inside exponent. So that 3 gets placed on the 2. It'll become 2 to the 3rd, which later becomes 8 because 2 times 2 times 2 is 8. The 3 gets distributed to that and it becomes x to the 6th, as you see here. 3 gets distributed to the y to the 1 and it becomes y to the 3rd. 3 gets distributed to the 5, becomes z to the 15th. So I call it the distribution rule, right? Whenever you have a monomial with parentheses, with an exponent on the outside, you distribute it to each and every term. Now, just to relate it to what we did most recently, we did a distributive property of a binomial times a binomial, right? So if you had, let's say, x plus 5 to the second power, you cannot distribute. Why? Because it's not a monomial, it's actually a binomial, right? Two terms. So in this case, which you will have this case on the midterm, you're going to have to write it twice. You're going to have to actually write it as x plus 5 times x plus 5. And then you're going to have to distribute, right? X times x, and then 5 times x, and 5 times 5, and then combine like terms. Anyways, that's unit 8. And right now we're focusing back on in unit 7, which had exponents. So we're not distributing. We are distributing the exponent into a monomial. Now, it could also be a fraction, as long as there's no like plus or minuses, like separating terms. You still distribute it to every single term. Right here, you distribute, put the power on the 3, that's 3 squared, that's how you get 9. Put the power right there on the 4, 4 times 2 is 8, that's how you get 8 right there. Put the 2 on the 3 right there, 2 times 3 is 6. We understand that, right? Understand that rule? Okay, so now let's move on to the next rule. Anything to the power of 0, that's the easiest one. Anything to the power of 0 equals 1. And the next rule, whenever you have a negative exponent term, you have to move it to the other side and it becomes positive. So that's why you have an x to the 3rd down here instead of up here. It moved down and it became positive. That's another rule of exponents. And the final rule of exponents is called, or I call it the canceling rule, where we have 3 x's up on top and we have 5 x's on the bottom. 3 of them completely cancel with 3 of the 5. Again, notice that I put a line even through the x because all 3 x's canceled out. There's no more x's. And I only put the line through the 5 because there's still some x's left. How many are left? There's 2 of them left. Why? Because 3 cancel with 3, leaving you 2 left over. So what's your final answer? There's nothing left up on top, but there's x squared on the bottom. Those are the 7 rules. I hope we understand them. We need to be able to identify them and apply them. This is back in Google Classroom, back in February. And this PDF in Google Classroom will also show you more examples of Rule 1, more examples of Rule 2, where you have a power to a power you multiply, more examples of Rule 3, where you distribute the outside exponent to each and every inside one, more examples of Rule 4, or this is Rule 5. It doesn't even matter the number. More examples of the rule where you have the power of 0 becoming 1. So that cancels out. The answer is 2. Power of 0, the whole thing becomes 1. Power of 0, the whole thing becomes 1. And we have more examples. So this worksheet is awesome to go back and review because it gives you tons of examples of each rule. Anyway, What are you going to see on the practice midterm? What are you going to see on the actual midterm? Questions like these. And we need to be able to simplify this. So what rule am I going to be applying on this one? The power of 0 rule. That becomes 1. So imagine if this x to the 0 became 1, it would say 5 times 1, and it would still be 5. So that's why I could just put a line through it. This z to the 0 cancels out. It's like if it became 1. Imagine it saying 5 times 1 times y to the 7th times 1. What's your answer going to be? 5y to the 7th. That's right, and that's your answer. Got it? So you're going to see questions like this. This was just of that single rule. Anything to the power of 0 becomes 1. Let's look at a different example. Here's a different example. If I were you, I'd copy this down in your notebooks, right? What rule am I going to apply here? Do I have the power of 0 rule right here? No. Do I have negative exponents that I need to move to the other side? Subtract, right? Or as I like to call it canceling. Because sometimes when we call it the subtracting rule, sometimes like you end up with negatives, and then if you did end up with negatives, you have to move them to the other side. I always say, think of it as canceling. We have 5 x's up on top and only 2 on the bottom. So both x's on the bottom completely cancel with 2 of the 5 up on top, leaving you 3 left over up on top. And as for the y's, the 1y that's on the bottom completely cancels out with 1 of the 9, leaving you 8. So far, that's our answer. 28 x to the 3rd, y to the 8th over 7. However, when you have a number over a number, that's really a number divided by a number, right? 28 divided by 7. At the very least, you could, even if you can't divide 28 by whatever this number is, you might be able to reduce it. But right here, you could divide 28 divided by 7 is what? 4. So 28 divided by 7 is the actual number 4, and that is up on top. So our final answer is 4 x to the 3rd, y to the 8th. Now, because I did not have anything left over on the bottom, I don't need to write over 1. We could just leave it as 4x to the 3rd, y to the 8th. That's your final answer. Do you get it? You're going to see some questions exactly like that one on the practice midterm and on the midterm Friday. Okay. Here's another one with the fraction. But what rules could I apply? Are there any powers of 0? No. Is there any like power to a power? No. Right? Is there anything I need to distribute from the outside of parentheses to the inside? No. What rule do you guys see that I could apply? Negative rule, right? Anything with a negative exponent rule must move to the other side. Now, some of us, I think I heard said cancel, right? We can't cancel yet. The only time you could cancel is if you have x's on top and x's on the bottom, and you might think that, hey, I have x's on top and x's on the bottom, but the reality is the negative exponent is going to force you to move it. So it's not really on the bottom. It's actually up on top. So it's not on the bottom. So you can't really cancel. You can't say, I want to cancel these. No, because you got to move it up, and it's not really on the bottom. It's up here now. So that would imply that you could actually do rule 1 right here. X to the 8th times x to the 3rd. What's x to the 8th times x to the 3rd? Rule 1 says you add them and get x to the 11th. That's right. And same thing with the y to the negative 4. You have to move it up before anything, and it becomes y to the positive 4. It's no longer on the bottom. So up here now you have y to the 7th times y to the 4th. That's rule 1 of exponents. What is that? Y to the what? 11th also. And there is your final answer. Why? Because there's nothing left on the bottom. It's kind of pointless to put it over 1. So you don't have to put it over 1. So there's your final answer. Y to the 11th, or x to the 11th over y to the 11th. Do you get it? I hope you do. Moving on. Got a couple more here. Here's one where we have to do what with that 3? Distribute. Yep. So put it here on the 2, put it there on the 6, put it there on the negative 4, put it there on the 0. Actually, even before distributing, anything to the 0 powers what? 1. So you can just cancel it out. That way you don't have to distribute it there. So what do we really have here? We have 2 to the 3rd, x to the what? 6 times 3 is 18. Yeah, power to a power, multiply. And then y to the what? To the negative 12. Okay. So we distributed. That was one rule. We canceled out the z to the 0. That was another rule. Is there any other rules that I could apply before I type in my answer, right? the exponent with the negative 12. Negative exponents have to be moved to the other side and they become positive. So the other side of what? The other side of the fraction. If you don't have a fraction, go ahead and make up or draw a fraction bar, get this guy, move it to the other side. So it's going to become y to the positive 12, and it's no longer up on top. So here's our answer. However, 2 to the third could be done. 2 to the third is not 6. It's actually 2 times 2 times 2. So what's my final answer going to be? 8x to the 18 over y to the 12. I hope we understand that. We're going to have some identical questions both on the practice midterm and on the actual midterm Friday. One more here. This one's so easy that people will actually, two more. And these last two are so easy that people get confused, right? People are like, oh, it has parentheses. I need to distribute. No, there's nothing to distribute. So you're just simply multiplying, right? What does this really say? Yeah, it says 3 times x squared times 5 times x to the fourth. It's all pure multiplication. So just do the coefficient 3 times the coefficient 5. What do you get? 15. And yeah, the x to the second times x to the fourth, x to the sixth. And that's your answer. 15x to the sixth. Let's look at this other ridiculously easy one that a lot of people get confused with. You can't cancel here, right? What do you got to do first? Move it. Move it up. It becomes positive. It's no longer at the bottom. And what is this? X to the third times x to the third. Yeah, x to the sixth. There's your answer. Why am I going over these easy questions? Because these easy questions come out on the midterm, right? Just maybe with a different number. Bless you. So hopefully you guys understand that and you ace this portion of the midterm, okay? Now, this was the first half of Unit 7, which was on the rules of exponents, right? You could find the notes early February if you need these notes, so you could go over those examples of the 7 rules. But the second half of Unit 7 was exponential growth and decay functions. Exponential growth and decay functions. So if you're like, man, I flunked Unit 7, you definitely want to be taking good notes right now. As a matter of fact, after we're done with this, you might be ready for a Unit 7 retake. Who knows, right? But right now, we're going to jot down the form that we're using for exponential growth or decay functions. Y equals a times base in parentheses to the power of x. In Algebra 2, you're going to have a minus h up here and then plus k at the very end. But it's Algebra 1. We don't have a h shift. Anyway, we need to remember certain things. Let's start with, I would think, the most valuable thing with the exponential growth or decay function, the number at the very end. This number, the k value, tells you your asymptote. Okay, so I didn't write it right here, but let's write down asymptote. And what is the asymptote? Well, it's going to be y equals k. So whatever number is out here, y equals that number will be your asymptote. And I hope we remember what an asymptote is. It's the horizontal line that your graph will infinitely grow away from or decay towards. Okay? So like, let's say I had y equals 2, I'll keep it simple, 2 to the x minus 3. Okay? Right here, our k value would be minus 3. That would mean that on a graph, 1, 2, 3, your asymptote would be right here. Does that make sense? So, let me not get too carried away. The k value gives you your asymptote, and it's that vertical line, horizontal line. I usually draw it in green, that your line will either infinitely grow away from or infinitely decay towards. So that's very important to write down. The k value is your horizontal line, y equals k, that your graph will infinitely approach or grow away from. Now, the b value itself, the b value tells you if it's growing or if it's decaying. So if your b value is a number greater than 1, like let's say 1.01, or a fraction like 3 over 2, that would be 1.5, or 2 or 5, or anything bigger than 1, that's going to be a growth function. But if b is between 0 and 1, as in if it's less than 1, but between 0 and 1, so let's say we're a fraction 1/2, that would be a decay if it's between 0 and 1. Okay, so 1/2, 0.99, anything value that's between 0 and 1, that's going to be a decay function. And in addition to that, something very important is your A value. If A is positive, if this value is positive, then your entire graph will be above your asymptote y equals k. If A is negative, your entire graph will be below y equals k. Do we understand what I'm talking about, or does that sound like a different language? This should be a review. Do we kind of get it? Any questions on this? So let's see if we get it. You don't have this in front of you, but watch the screen here. We have all of these graphs, and some of them are growth functions, some of them are decay functions, okay? And what we need to determine is if they are growth or they are decay. How do we do that? From left to right, if the distance from your line to the asymptote, you see right here's the asymptote at -3. That's y equals -3. That's a k value of -3. Right here's the asymptote at +1, okay? Right here is the asymptote, the k value is -1. Right here, the asymptote is at +4. Right here, the asymptote is at +4 as well. Right here, the asymptote is at y equals 0, the x-axis. Right here, the asymptote's at y equals 0, the x-axis. Right here, the asymptote is at y equals -1, right? I hope we understand the location of the asymptote. So the question is, from left to right, does the distance between the line and the asymptote grow or does it decay? Does this grow away from the asymptote or does it decay towards the asymptote? This is what? Growth or decay? Growth. Because from left to right, look, I got my asymptote and that other dot, that's a short distance, but from left to right, the distance is growing, growing, growing. That's why it's a growth function, because from left to right, it grows. This one is not a growth function. From left to right, what's happening to the distance? It's decaying. Make sense? This guy right here, there's a distance. From left to right, what's happening? Decaying, decaying, till it looks like it's touching. Right here, from left to right, what's happening? Decaying. The distance between the two red dots are getting closer. Right here, from left to right, what's happening? It's growing. The distance between the two red dots, between the asymptote and the graph itself, is growing. So that's a growth function. Right here, what's happening to the two red dots? Growing from left to right. So that's a growth. Right here, what's happening between the two red dots? Growing. Right here, what's happening between the two red dots? Growing. Make sense? So that should be a piece of cake, knowing if it's growth or decay just by looking at it. Now, it might be a little bit more challenging if you're deciding whether it's growth or decay just by looking at equations, okay? So you would have to focus in on your B value, the base, to see if it's a growth or decay. Is this a growth? Yes, because the base, the B value is greater than 1. And that makes sense because if you multiply anything by 2 or anything greater than 1, it's going to grow. Is this a growth function? No. Growth? Yes, but in a negative direction. Remember, the A value, the number that's out in front, tells you if your graph is above the asymptote or below the asymptote. So growth, decay, growth, decay, decay. Again, if the A value is positive, if the number out in front, like if you actually had a number, right here we have a negative, that means that your graph will be below the asymptote y equals 4. So if you look at this guy right here, is the A value positive or negative? Is it above the asymptote or below the asymptote? This graph is all below the asymptote y equals 4. Does that make sense? So that must mean that the A value is negative. Same thing right here. The A value must be negative because the entire graph is below. Right here, the A value must be positive because the entire graph is above the asymptote. Okay? Anyway, even better, check this out. Let's all focus in on this graph, number 4. Here's a question on the practice midterm, maybe even on the midterm. You have this graph, and I want you to select which one of these represents this graph. Could it be the first one? Well, what's the K value? 3. That must mean that my asymptote is at 3. is my green line, my asymptote, at 3? No, it's at 4. So that automatically eliminates A. Make sense? Option A. Not only that, guys, this one's a growth function because the base is greater than 1. That must mean that from left to right, my distance from my asymptote to my graph should be growing, but it's actually decaying. So just by knowing that from left to right, it's decaying, 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 I know that it has to be a decay function. It can't be option C either because that's a growth function. Are you with me? Okay, so could it be B? No, why not? Because that has the K value of 3. That would imply that my green line's at 3, but we know it's at 4, so it can't be that one either. So out of these two, which one is it? They're both the same. Typo. My bad. I apologize. Yeah, I should have done one positive and one negative. Yeah. Yeah. Okay, so how about this? Let's make this one positive and make the bottom one negative. So which one's the correct one? E. Because the A value tells you if it's above the asymptote or below the asymptote. Yeah, it's a negative, which means it's below the asymptote. Okay. So, I mean, there's a lot of details, but I hope I've explained it to where you're starting to get it. And you could always go back and rewatch this video lesson to make sense of it more. Okay. So if this would have been like, if this graph would have been like, let's say up here, like that, it's not. But if it would have been up there, then the entire graph would have been above the asymptote, which would have said the A value being positive. But it's below the asymptote, which means that the A value is negative. Anyway, I hope we get that. Let's say I asked you to actually graph. If I wanted you to graph on quizzes, all you got to do is go to an input-output table, get your calculator, and plug in an easy number like 0, okay? And you could type in 0 right there on the calculator, a minus sign, parenthesis, the fraction 1/2, type in a 0 right there, plus 4, and then hit equal, and your answer will be 3. Now you're thinking, what the heck? You didn't even do it with the calculator. Yeah, because it's pretty easy to do in your head. Anything to the 0 power becomes 1 with a negative in front. That's a -1. -1 plus 4 is positive 3. And then you could plug in another value with your calculator, maybe like 2, okay? So if you did, or like 1, whatever, keep it easy, 1. If you did plug in a 1 right there, you'd end up with half, which is -1/2, plus 4, that would be 3.5. So you already know that it has an asymptote at 4, 1, 2, 3, 4. Here's your asymptote. How do I know that? Because the K value is 4. And then you have the coordinate 0, 3. I'll graph this one in green. 0 on the X, 3 on the Y. There it is. And then 1 and 3.5. 1 on the X, 3.5. So that would be even closer. What the heck? Even closer to the asymptote. So as you can see, this way it's going to infinitely approach it. And this way it's going to grow away from it. So that's how to graph by hand or with your calculator, right? Anyway, I hope this helps. I'm going to end it here. And we'll do another video explaining Unit 8, the first half of Unit 8.